Hello, my name is Christopher Somali, and I'm here to showcase a demonstration of the ECE 4122 Advanced Programming Techniques final project, which is running a 3D chess game. So, to begin off with this demonstration, I will share my screen and showcase my Visual Studio Code and proceed to clean the build folder, then build it. Now that the build's commenced and it takes a while to load, I'm going to showcase the ECE chess game class, which is a wrapper for the Komodo chess game engine. It allows OpenGL to create a chess game engine instance and allow the user to be able to send moves to the engine and receive moves from the engine as well. So part of this class has some properties such as input and output, writing and reading capabilities to this pipeline. Has a constructor, deconstructor, initialize engine, um, send moves, as well as get response moves, which is implemented within the .cpp class and then called within our main um, loop, which is within OpenGL underscores 3D chess.cpp. But to go over this CPP file for the chess game engine, um, we have some of the properties of extended from the template from with by including start engine, send engine, and read from engine. These allow us to be able to pretty much set up the properties such as like being able to read the executable file for Komodo 3 for 64-bit Windows system, then also being able to send commands and read commands from the engine. But those are later expanded within these other files, these other functions. More specifically, I'll take more note into the send moves as well as response moves functions. So for the send move, we're able to output a position of a chess piece, and and then the engine will be able to read and like compile like 10 different moves, which they will be able to the player two would be able to potentially use, and then it will like from the response of the engine will then pick the best move and output it to the terminal. Now, within the OpenGL 3D chess CPP, we have a really big try-catch block, which essentially allows the user to be able to um, type in commands into the command slash moves into the command line terminal, and it would be read in, and they can be able to do a set of these type of moves, either quit, which closes the game window, power, which turns up or down the brightness level of the lamp, light, which modifies the light's position, camera, which modifies the camera's position, as well as move, which is moving the chess pieces. Now, since we've completed building the project, I will then go towards um, continue moving towards the the executable for lab for this project. So one moment. Let me be able to find this executable. And then I'm going to replace it within this folder. I'll run the game application and then begin to showcase the rendering of the 3D game of the 3D chess game as well as how the user will be able to input command slash moves into the terminal. So I'm gonna make this a bit bigger. Right now it's rendering the model matrices, the view matrices, as well as the projection matrices. So uh, to start off with, the game begins in with the camera being oriented on above the chessboard on the negative Z axis, and I can begin with some of the lighting commands so that you can be able to better illustrate see the markings on the edge of the board itself. So if I was to turn up the brightness by inserting power, let's say 400, now you're going to be able to see like maybe let's go power um 700. Now you're going to be able to see some of the columns and rows labels like from A to H as well as from 1 to 8 on the chessboard, as well as being able to see all of the chess pieces being properly placed onto their square. Now, if I was to go and now move this light source, I'm going to reduce the power, the brightness of it back to default. Now, if I was to move this light source to another position, I would be inputting the light command, and then let's move it to 222. So now it like shifts a little bit closer to the board as well as to the left more. Let's go with light um uh 5, 10, 20, 10. Now it's a little bit offset. Now if I went placing the light back towards its like defaults position, um maybe I can also showcase that it is if we move the light a little bit more like higher above the chessboard and then showcasing it moving closer towards the chessboard where it has a really big focal point. Now I'm gonna go back to default and then I'm gonna increase the brightness to like 400. Now, if I was to now I'm gonna showcase checking for illegal moves. Sorry, checking for illegal lighting parameters, such as ensuring that it has at least that there are enough parameters and that the light is fixed on a position which is in a positive quadrant or positive octant. So let's say the user inputs way too many commands, like the terminal output too many arguments, or say that the user inputs too few commands, too few arguments, and it prompts an error and prompts the user to try again. Now, let's say that the user tries to place the light source below the chessboard, for instance, or way too offset from the main view. And then it will provide the user mentioning that please select a light position with an XYZ coordinate value greater than 0. Next, I will demonstrate how, for instance, like if the user forgot to input the a parameter for power, the console will output there are too few arguments for this particular command for power. Next, I will go through showcasing the oh, as well as I can showcase that if the user inputs a value for power that is greater or less than zero, there will also be an error. So it will output to the terminal, please select a light power value greater than zero. Now, if now I'm going to showcase the camera commands or camera, like being able to move the camera to different positions within this window. Um, so to be able to do that, just type in camera and say, let's go to the theta value is 10, the tau val the phi value is 45 degrees. And this is all in degrees, but it's converted into radians. And then the radius is 50. Now it will shift the camera placement. Now let's say let's do 95. It will repivots the camera position. Now let's go to like 120. Sorry, not one, not 12. Let's say it's 80 and 90. That's a little bit better. Um, that'll showcase how the camera can the the constraints for the cameras the constraints for where the camera can be placed or it's like its angles of rotation or angles of like position. So the camera cannot be placed with theta values less than 10 or greater than 80. So if I was to put in, like for instance, 5 for its theta value, the terminal will output invalid camera position parameters, theta angle is out of range. Now, if I was to showcase this for, let's say, 85, improper, same terminal output, the theta value is out of range. Now, if I was to go back to, say, 80, now, the phi value can only be is constrained within the range of 0 to 360. So let's try to do a negative number, for instance, like negative 10. The terminal output, phi position, invalid camera position parameter, phi angle is out of range of 0 to 360. And let's do this again, but for the upper bound case and same terminal outputs. Now let's check to see if um for the next constraint, the radius must be greater than 0. So for instance, if we gave a negative value for the radius, sorry, it's short circuit evaluated for the phi angle. So now for the terminal output for the radius it's mentioned invalid camera position parameter. Radius is out of range from 0 to infinity. Because we insert a negative value, but if we insert a positive value, like say for instance, it's very small. It'll be like super zoomed in, but still kind of towards the center of the board. Now let's go back to like 50. Oops. And let's make this like 90. 80, 80. Now, this demonstrates the constraints for moving the camera, as well as checking for illegal moves and commands. Finally, I will showcase the e the ability for the user to input uh chess moves so that they can be able to move their pieces along the screen. Now, with this, we first check to make sure that there are enough like token or enough parameters input into the system. So, for instance, if it's move, uh, the terminal output error too many or too few arguments. Um, and if say we did like E2, E3, and then some other parameter, it'll also propagate an error. Now we will showcase a valid move, and the terminal output provides the so once we provide a valid move the into the terminal, it's read in by the main program, sent to the Komodo game engine, which then processes this player move, determines the robot's next best move for player two, and then outputs it to the terminal and gives like another suggestive like move that they could also be able to make. And let's try another move. For instance, let's go from D2, let's say C2 to C3 for one of the pawns moving forward. And then the game engine outputs another best move um, for the next player, for player two. So, for instance, maybe if we wanted to showcase some of the illegal or invalid moves, we can do like a user input that may not have like um, a corresponding row or column that is on the chessboard. For instance, the chessboard is bounded between um its rows are bounded between A to H and its columns are bounded between 1 to 8. This will output an error because of the fact that N is not within the range of A to H. So this is being shown on the terminal. Illegal command slash move columns must be within the range of A to H, and rows must be within the range of 1 to 8. Next, I will showcase um, same process, but let's say for providing a number or a row value which is out of range. Um, let's say it's B2 to B9. Same type of terminal outputs, saying that it's out of range. And this is checked with by checking the corresponding character and making sure that its ASCII values within the range of A to H for columns and 1 to 8 for rows. And there's some error handling for if the chess game engine send move or get response move doesn't properly send it to the Komodo game engine. And yeah, the next last bits of commands that can be inputted by the user is quit, which will end the session and close the window. And Thank you for watching my demonstration. Hope you have a good rest of your day. Peace.